Yeah, now let's look at the circuit connections of SCR characteristics. This is the circuit diagram. We have two power supplies here, PS2 and PS1. I have used this power supply as PS1 and this one as PS2. Okay, according to the circuit, first from positive of PS2 it should go to a switch, then from switch to ammeter, then from ammeter to rheostat. Let's look at the connections. Here we have from positive of PS2 it's going to switch, from switch it's going to positive of ammeter, from negative of ammeter it's coming to rheostat, and rheostat other end is going to 1k rheostat resistance, and another connection it is going to gate. Now from positive PS1 it's going to fuse, from fuse switch is it's going to switch, from switch it is going to rheostat, from rheostat it's going to positive of ammeter, then from ammeter it's going to anode of SCR. Here one more connection is left, that is from 1k resistance again it is going to cathode of SCR, and positive negative of PS1 and negative of PS2 is connected. Next we have connected ammeter here, then the voltmeter is connected across anode and cathode of SCR. One point to be remembered here, in your manual wherever ammeter is mentioned you need to go with digital ammeter, wherever the ammeter range is milliampere you have to go with multimeter. Now let's start with the conduction. First I am turning on both PS1 and PS. Now what we have to do, initially we have to make sure that both are at 0 and switches are in off state. Now I am going to set this PS1 to 30 volts. Set PS1 to 30 volts. Set PS1 to 30 volts. Now turn on both the switches S1 and S2. Okay, when you turn on both the switches S1 and S2, you can observe that the voltage across SCR is same as the supply voltage PS1. It indicates the SCR is in off state. Now we are going to turn on the SCR by providing gate current. For that I am going to vary PS2. Vary PS2 slowly and observe the voltage across SCR and current through the gate. Okay, whenever SCR turns on, the voltage across SCR goes to 0 and that value of current we call it as gate current. So our eye should be on the voltmeter. I am increasing the voltage and I am going to stop the variation of voltage when the voltage across SCR goes to 0. Yeah. Now at this point the voltage across SCR has gone to 0. So this current which is gate current, this ammeter is connected to gate. So this ammeter shows the gate current reading. So we need to note it in the gate current tabular column. Threshold gate current Ig equal to 6.4 milliamperes you have to write. PS1 we had set it to 30. Ig equal to 6.4 milliamperes we have to get. Now after turning on the SCR, we should not disturb the gate side part. Leave this as it is. Now what you have to do is vary the rheostat. Vary the rheostat. Initially rheostat was kept in maximum position. Now I am reducing the rheostat and now I am varying the rheostat and I am noting down the voltage across SCR and current through the anode. This is the anode current. Note down the values of voltage across SCR, current through the SCR, that is anode current, by varying the rheostat. Okay, you can note down the readings from the video itself. It's 0.795, 0.27, then 0.797, 0.28, 0.802, 0.31, 0.806, 0.35, like this. You can reduce the rheostat till 50% and note down the voltage across SCR, current through the SCR. Thereby we can draw the characteristics of VI characteristics of SCR. After doing this, everything you have to set back to normal position. Now I am reducing or increasing the rheostat to maximum value. Then I am now after completing it for 30 volts, you have to perform it for 20 volts. Okay, now again you have to set the voltage to 20 volts. Repeat the procedure. Again, set it to 20 volts. Switch on both the switches. Switch on both the switches. Now this gate side voltage is 0 and voltage across SCR is showing 20 volts. Now increase the gate current slowly and note the gate current whenever the voltage across SCR goes to 0. So 8.2 milliamperes. So this is how you find the gate current. After finding gate current, don't disturb this part. Again vary the rheostat and note down the voltage across SCR, current flowing through the SCR by varying the rheostat till 50%. Now let's look at the connections of latching current and holding current. The circuit connections for latching current and holding current are shown like this. Okay, now this is PS2, this RPS I have taken as PS2, this RPS I have taken as PS1. Okay, from PS1 positive, it's going to switch from switch to 1K resistance. From 1K resistance, it's going to gate. Now from PS1 positive, it's going to switch. From switch, it's going to 500 ohm resistance. From 500 ohm resistance, it's going to 110K variable port. This is the variable terminal. And from other end, it's going to positive of ammeter. From negative of ammeter, it's going to anode of SCR. From negative of SCR, it's going back to supply negative. Negative of PS1, negative of PS2 is connected here. And voltmeter is connected across SCR terminals. Now what we are going to do here is, we are going to find latching current and holding current. For that, let's switch on the supply. Let's switch on the supply. Now make sure S1, S2 are in on state. Give the supply voltage, main supply voltage to 30 volts. Increase main supply voltage to 30 volts. Now SCR is in off state. As a result, we can see the voltage across SCR is 29.3. Now I am going to increase gate side supply and I am going to turn on the SCR. Yeah. Now SCR is in on state. The voltage less than 1 across SCR indicates it is in on state. Now, in order to find latching current, what we are going to do is, initially I had kept this pot in maximum position. Okay, this resistance is kept in maximum position initially. We have given the maximum voltage and gate current is also sufficient. Now, what we are going to do is, we are going to reduce this part and we are going to increase current flowing through this part. As a result, we are going to find latching current. At one point of time, we will get the latching current. What's the procedure is? Now slowly reduce this resistance and the current IA. This ammeter is connected to anode of SCR. So this shows IA. Okay, IA will increase. I am reducing the pot resistance value. So the current is increasing. Now after a certain point of time, I'm going to turn off the switch S2 and I'm going to check whether the SCR is in on state or off state. For this anode current, whatever it is flowing in this, the SCR is in off state. That means this much anode current is not sufficient for SCR to retain in on state. Now again, I'll switch it on and I'll reduce this resistance further. The current increases further. Current is increasing further. Now let me switch off once again and check. The SCR has gone back to off state. The voltage across SCR is 29, indicates it is in off state. Now I'm turning on the switch once again and I'm going to reduce the resistance. Now let me switch off and check. It's again in off state. I turn it on, then again reduce the resistance. Now let me check at this point. Still it is in off state. So I'm going to close the switch S2 once again and I'm decreasing the pot. Okay, now let me check. Now, if you observe, I have turned off the switch. I have turned off the switch at the gate side. The current flowing through the SCR retained the SCR in on state, indicating the voltage across SCR is less than 1. So we need to find exactly this point of anode current, the actual point of anode current at which SCR will remain in on state even if you remove the gate pulse. This is what we need to find. Now, after finding this, in order to find holding current, we will be keeping the switch S2 in off position only. We'll be keeping the switch S2 in off position only. Now slowly increase the pot. Now slowly increase the pot and observe the ammeter. At one point of time, the ammeter current will jump to 0. See, from 15 milliamperes to 0 milliamperes it jumped. That means till 15 milliamperes the SCR can retain in on state. Below 15 milliamperes the SCR couldn't stay in on state, so it went back to off state. Okay, that 15 amperes was holding the SCR in on state, so we call it as holding current. So 32 was the latching current, 15 was the holding current. This proves the relation between latching current and holding current also. Relation is latching current equal to twice or thrice the holding current. This is how we can do latching current and holding current.